Hey there, everybody. We are going to go ahead and start our walkthrough for Exercise 4. So this lab is on displaying XY data on coordinate systems, and like taking another look at coordinate systems for migration information on the northern shoveler, which is a duck. So we're going to get started, but we're not actually going to start here in ArcGIS because we're actually working with a spreadsheet that we're given, and we're going to input the data on that spreadsheet into ArcGIS before we can work with it. So what we're actually going to do is we're going to pull up our data that we've unzipped, extracted from our zip file. We're going to see that it is an Excel file, so we'll open that, and it'll open up in Excel. Now, for the first thing that we're going to do, and this is a great thing to do if you're ever given something, a task where you're given a file in Excel that you need to put into Arc, so we're going to familiarize ourselves with the data. So up here we can see there appear to be a bunch of headers on line 1. We have band ID, it looks like, the sex of the bird, the band region, the recovery region, so the region in which the duck was banded versus where the band was recovered. Recovery year, banded year. This looks like banded latitude, banded longitude, and then recovery coordinates. The condition when it was recovered, you'll see the vast majority is dead, with a few unknowns in there. I imagine they just recovered the collar and there was no bird. And then how obtained is how the bird came to be dead. So many of them were shot, some of them were just found dead or caught due to injury. So see here, unknown, caught due to injury, right? Now that we've kind of taken a look at this, and we can kind of begin to see where in the US these, well, just like, not just US, where on the globe that our kind of like range is going to be for where they were banded and where they were recovered. You can go ahead and get this uploaded into Arc. So we're going to go ahead and we're going to add the folder into Arc. Forgot to make a folder connection. So I'll go ahead and do that really quick. If I can find my folder. There we have this. So now that so what we're going to do is take our data here, now that it's connected, and we're just going to drag and drop it like we normally do. And you'll see that it's added to Arc now, to our map, but it says standalone table. It's because there's nothing to really do right now. So we're going to display our XY data, and we're going to tell it what table to use as its input, and we're going to give it an output feature class. I'm going to call this end show for Northern Shoveler, and then data. Now this X field, I don't know why mine has automatically populated itself. It shouldn't. But my X field is going to be B long, because I'm going to do my banded shapefile first. I need my latitude for our banded and our longitude for our banded. Our X field is going to be our longitude. Our Y field is going to be our latitude. And our coordinate system, just make sure that this is what we want. This is not what we want. Our coordinate system is going to come here, geographic, North America, USA and Territories, NAD 1983. Now, pause, because we're not picking this just arbitrarily. We need to make sure that we're using the same coordinate system that was used for gathering this data and compiling this data. Now, there are a couple ways you can go about figuring this out. You can do a deep dive in a Google search. Maybe if you were sent this by someone in an email, they would tell you, or you could ask. For us right now, we know that it is supposed to be the North American datum of 1983, NAD 1983, because our instructions tell us that the USGS Bird Banding Laboratory website, that website tells us that this is what we want. So click OK now. And now that we have the correct input table, good name, the correct fields, and the correct coordinate system, we should be able to populate some data. So there we go. That is now our banded data. And I've just realized that I didn't name this super great. So I'm going to come in here. If you ever need to rename anything, you want to right click, come down here to properties, general name. So I'm going to do is in show band. And now I'll be able to remember that this is the banded data, because now what we're going to do, I'm going to come back to this table. We're going to run that process again, but for the recovery data. I'm going to say recov, so that's pretty close. Then rlon for x and rlat for y is still the correct coordinate set. Click OK. It's going to run this. And now we have our data. So I'm really quickly here just going to make these a different color so that it's a little bit easier to tell apart. I'm going to go ahead and make this one orange, or recovery band orange. And I'll make this one a slightly brighter blue. And I'll make it green. All right, so it's a little ugly, but it's going to be easy for me to manipulate and work with. And when it comes time to visualize this, I can go back in and make it pretty. So in this next step of the exercise, we're going to be making a few measurements of the migration distance of one of the birds, right? And we're given the band ID that we're going to be working with. So the first thing we're going to need to do is select the band ID from both attribute tables so we make sure we're working with the correct bird. So I'm going to come up here to the ribbon, come to map here at the ribbon. I'm going to click select by attributes. I'm going to set the input row to our banded data, new selection. And I want to make it so the band is equal to our number. I'm just going to type it because there's going to be a lot of numbers in there. Number is 059651148. 51148. Yes, okay. And I'm going to click apply. And now we see that this bird was banded here in Canada, in Saskatchewan. Which is the answer to your second question. Seem to have skipped your first question. Your first question that you should be able to answer is whether or not the data sets with latitude and longitude coordinates are a geographic or projected coordinate system. Making a note real quick. 9B. So is what we're working with when we have our latitude and longitude geographic or projected? I'm going to give you a hint because we're working with coordinates and degrees. They're not really projected onto anything. So a little bit of a spoiler there. And now question 2 is this bird, bird 05, blah, blah, etc., was banded in what region? So that would be the area in which it was banded. In this case, it's a Canadian province. Now we want to know what year it's been recovered. So we're going to leave this selected. And what we want to do is select the recovered point location for the same bird. So we're going to use the select by attributes again, but we're going to make the input row from end show recovery, and we're going to make our selection add to current selection. So we keep where it was banded, we just add where it was recovered. And then this is still correct here. Click apply. And now we have a problem. That's interesting. So it seems like ARC does not believe me that I have something selected, which I do. Well, it's very interesting. Oh, and it looks like it doesn't really matter because I have my recovery point here. So I'm not sure entirely what that error was, but I have both my recovery and my banded point. At least I should. So what I'm going to do is go too far. There you go. Check this point by clicking on it. Band is 05965 1148, which is what we want. And I'm going to come up here to this selection, 59651148. So don't know what that error really was, but for now, I'm simply going to let it be because I have what I need anyways. Another way to check, which is going to be especially helpful for your question 3 when you want to know what year it was recovered, is to open the attribute table for both the banded data and the recovery data. You'll see we have one selected here and one selected here. Total selected features up here is 2. So come here to recovery and find where the bird is by sorting by selection to get that answer to question 3. Now we're going to move on to measuring distances. I'm just going to shrink this down real quick so I have space to work with. Okay, so the first thing we want to do is measure the distance between where our bird was banded and where it was recovered based on the coordinate system that we're currently in. Now we're in a geographic coordinate system, not a projected one, which means that when we use the measuring tool, we're going to be using a geodesic distance, which the geodesic is a measurement. It's the shortest distance between 2 points on an ellipsoid. So it's taking the shape of Earth into account, versus a projected one will be a regular distance measurement like a meter or a mile. For right now, we do want geodesic. So what we're going to want to do is zoom in as much as we can while keeping both of the bands in frame, which appears, so it might be this. Wonder if I can get it to go in just a teeny bit more by customizing add our current one, maybe. There we go. And I can't adjust this, can I? Oh, yes, I can. 115. No, I don't think that worked. Okay, well, it was worth a try. For right now, it looks like this is going to be about as close as I can get. You want to be as close as possible because it's going to keep things as accurate as possible. So we're going to come here to the measure tool. Our measure tool, going to select this, Geodesic. Now, typically this will start you off as Geodesic Imperial, but we know based on our question 4 that we want to know the distance to the nearest kilometer using the geodesic distance. So we're going to go ahead and select our point. I'm going to go from banded to recovery. You'll see that it's kind of highlighting these points for you to make it a little bit easier. So I'm going to come up here, select that as close as I can, and come down here to my recovered point. Remember, they're the two that are highlighted because of our selection. Click that. And, oh, whoops. Well, technically what you can do, just make another segment here, you double click when you're done. So now I have 2 segments. The important segment is this first one, which is 2,634 roughly, rounded to the nearest kilometer. So that's our distance between where our bird was banded and where they were recovered. I can close this. Note of caution though, you do not want to use degrees. Your assignment warns you, degrees is not a choice here, but maybe stay away from imperial anyways, or metric, just because they're not very helpful. So stick with one of the ones that are going to be helpful to you. Okay, in this next section, we're going to be changing our display coordinate system. So we're going to be taking this geographic coordinate display and projecting it so that we have a projected coordinate system. So the first thing I'm going to do is I'm going to clear my selection so that what I'm working with is going to be a little bit cleaner. And then I'm going to take note of the data that I'm trying to project. Now I have locations all across North America, from Alaska through Canada down to Mexico, right? Now, this means that I only have a few options that are going to keep this data in mind to keep it as unwarped as possible. So the things that you need to keep in mind when picking this is the extent, which is for us what we just said, Alaska to Mexico, and the metric that we want to preserve. So our area or the angle or the distance or any shapes. So go ahead and think for yourselves and take a look through the coordinate systems in your properties and think about which coordinate system you think will be best in this situation. Okay, now the metric that we want to preserve in this case is distance, because the whole goal of this project is stated in the background up at the top, is that this data is being used to measure the distance between their summer grounds, the birds' summer grounds, and where they were recovered, which is primarily where they were in the winter. So our distance is going to be what we want to preserve in this case. We're going to do so by coming up here to properties. For our map, by the way, we're adjusting our map, not our data. You're going to come here to your map and adjust your properties to your projected coordinate system. You have a couple of different options here, but we want something that's going to preserve our continental extent of North America. And we're going to look for something that's going to preserve our distance. Now you can typically tell what everything's going to do. So you've got equal area, contiguous with your Albers, you have your Lambert ones, And then you have equidistant. This is going to be the one that we want. So we're going to select that, click OK, and allow ARC to get everything sorted. And now we have our map projected onto a coordinate system. Now, make a note that we have not changed the data by changing this display system. So nothing is changed with the locations to make the locations accurate to what we're projecting. So to permanently change the coordinate system of our data, we're going to need to use a geoprocessing tool called the project tool. I'm going to come here, find tools, project, data management. And you guys are pretty smart. You've set up tools before. Go ahead and give it a try. And we'll come back here, see how to set this up. So we're going to do, at your back, we're going to take our input feature class, and I'm going to do the banded first. Input is going to be the banded. And our output, I'm going to, this is just our name. Oops. And I am just going to shorten this to P, to Pro, so it's a little bit shorter, easier to find. And our output coordinate system, you can either find it, again, by clicking this, tracking it down here, or we can be a little lazy and let it automatically fill it in by selecting the map in this drop down, because it's going to pick the coordinate system for whatever layer we choose. So pick the map. And we don't need to worry about this geographic transformation. If we come here to this little information, we can see that this is used to convert data between two geographical coordinate systems or datums. So if we were going from our North American 1983 datum to, I don't know, some other NAD 1927, this would be what we use it for. But we're not doing that in this case, so we can just leave it. And we're going to click Run. And now we have our projected data. You see here, if we zoom in here, we can see that there's not a ton of difference between the bands, between the two different options, right? But we know for sure that these ones are projected. So we're going to make sure to go with that. And then we're just going to run the tool again for our recovery data. I like to make sure that everything is named the same, like our base name and show, and then we have recovery and band so that it's all together in your data folder in case you have to go in there. Correct coordinate system, run. And now we have our recovery sites. So now what we're going to do is we're going to measure our distances again, but with a planar focus instead of a geodesic. So I guess I did this the hard way and I got rid of my points. I'm going to select by attribute again. Find our bird. Let me find that number. Where's our bird? There we go. Bye. So it's going to give me something that should be right here. Hold on. Oh, okay. So you see what I did here is I tried to select by object ID, which is not the correct thing to select. As we can see, I have 0 records. I'm going to click clear really quick because, again, 0 records is not the same as no records. And I want to have no records. Now when I refresh that, I want the band to be equal to our bird's number. And now when I do that, we see that we have our bird again. Okay. And then I'm going to do this real quick for our band pro so that I can see it. Add to our current selection. Apply. It's going to yell at me again, but I still have both my points, so I'm simply going to ignore this warning. Okay, so now I'm going to zoom in to the map again until I can see both my points. Can't go any further than where I'm at without losing them. I'm going to come here to our measuring tool, measurement, and I'm going to clear our results so that I don't get confused. Now I want to make sure that this is planar, which it should let me do. Alrighty, I'm back. I am not sure why it wasn't letting me select planar before, but what I ended up doing was just restarting the program. I made sure I saved, closed the program, reopened it, and then when I clicked measure, it allowed me to select planar measurement. So we'll just continue on. So yeah, here we have that we're going to be measuring in planar distance, or planar distance. And we're going to want this to be kilometers, again, based on the question that you're answering. So we're going to click as close as we can to this dot. Good enough. Then we're going to come here to the recovery site, as close as we can. And I have forgotten to double click again. But as you can see up here, this segment was 2,621 kilometers for our planar distance. A quick note on distance, it can vary. So if I were to zoom out a little bit and try to do this, I'm being much less precise with where I'm placing my tool, even if it looks like I'm going to the same place, and you'll see, oh, well, I'm simply amazing. That is a benefit of having this little point snapper tool. It seems to keep you pretty solid. But there are instances where you'll measure something and then you'll try to measure the exact same thing and you'll end up with a different number, right? So you can see the first time I measured that distance, 533, the second time was 525. So there is a level of uncertainty in your distance measurement, especially if you were to try to measure between like cities. So I'm trying to measure between, I'll give it a minute to come back in here, St. Louis and Kansas City. Now I can do this, and I can do it again and get slightly different measurements, but also, what is this dot that's representing the city? Because Kansas City is a pretty big area, and so is St. Louis. So there's a level of uncertainty with the distance measurements you're going to get in ARC. Don't worry too much about getting it wrong for your assignment. There is a range that we expect you to be able to fall into. So as long as you are selecting the correct points and you've got yourself zoomed in as much as possible, you're going to get a measurement that is within that expected range of measurement. So yeah, that's measuring. And that's also the end of our instructions. So now it's time for you all to create your layout and display your data. Now, a few important things to note about displaying your data. You are not displaying a map for this assignment. You are displaying a figure. A formal figure does not need a title, so you don't need to include a title on what you submit. You just display the data, your data credits, and describe the map contents and its purpose in a caption. You want to make sure you're displaying both the full set of both layers on screen. That wasn't very clear. You want to make sure you're displaying all of your data, right? So you're going to have to adjust where you are. Real good trick is to select one of your areas and zoom to layer. And this is gonna, you can just shift this up. And this is gonna help do the heavy lifting of getting yourself in a spot where you can see everything. You also should create a legend so people know what they're looking at. Fiddle about with your symbology so that the colors are a little bit nicer than this really aggressive Christmas color scheme I've got going on. And include a legend so that people know what they're looking at. So mine would tell them that these orangey red dots are where things were recovered, and the green ones are where the birds were banded. Make sure you don't include the word legend in your legend, any jargon regarding the GIS system itself, or any underscores, or anything that is like any redundant or unhelpful descriptions of things that are already explained elsewhere. Really, your legend should just be to add to your reader's understanding by telling them what they are looking at. So in this case, all they need to know is that the green dots are the banded location and the red dots are the recovery location. And make sure your numbers are rounded if you have numbers in your legend, which you shouldn't really in this instance, but you want to make sure they're rounded and have units to make things a little bit nicer to look at. Typically, you want to round to the nearest whole number, but again, you don't particularly need to worry about that in this case. Also, make sure that you add a caption. So you want to include what the figure is showing, the data credits, and the projected coordinate system. And if the display coordinate system is different than the data's coordinate system, tell us what that is. So the display is this coordinate system, which in this case, they are not different. But if they were, you'd want to specify. So yeah, those are the things you'll need to include. Final submission should include a single document containing 2 formal figures, each with a legend and a caption. One of those figures is going to be this data presented with the geographic coordinate system, NAD 1983, and the other in the projected coordinated system, which we're looking at right now. And make sure you include in your caption the full name of the display coordinate system. So don't just say geographic or projected. Tell us exactly what it is if we were to like look in the properties kind of a thing. And make sure you give credit to your data sources, which in this case is just USGS and Esri if you use a base map, which you probably should in this case. Make sure you remove your service layer credits and submit your answers to the questions in your instructions. Submit those to the quiz on Canvas. And other than that, good luck, happy mapping, and I will see you all next time.